Next up, we're going to talk about solving and graphing quadratic inequalities. Now, much like solving and graphing linear inequalities, you're going to find some of this very similar to what we did in step 10 when we were just solving and graphing quadratic equations. Specifically, when we're talking about graphing. In order to graph a quadratic inequality, we just graph the quadratic equation that would be related to that function. Then we're going to test a point and decide where to shade. Let's practice. So for our first example here, we have y is less than or equal to x squared plus 2x plus 4. So I'm going to graph this. I'm going to graph it strictly by hand. I know I have graphing technology at my fingertips that I could use, but I'm going to start by finding the vertex, which is negative b over 2a, which would be negative 2 over 2 times 1, or negative 1. So I know part of my vertex is negative 1. Now I need to find f of negative 1, which is negative 1 squared plus 2 times negative 1 plus 4, which gives me 1 minus 2 plus 4. That gives me 3. So negative 1, 3 is my vertex. I know this opens up because A is positive. I know I can come up with a whole bunch of other points that I could use around this vertex. This is also my axis of symmetry that goes right through the center here. So I know my parabola is going to be symmetric about that area. What about 0? If I put a 0 in, 0, 4 is a point. 0, 4 right here. Buy one, get one free, I get that point. How about the point 1? 1 squared plus 2 times 1 is 3, plus 4 makes 7. 7 would be right here. Buy one, get one free. We also get this point over here. So I have a picture of my quadratic. There's the graph of it. Now I need to decide where to shade. Well, I love using 0, 0 unless that's on the quadratic because it's an easy point to plug in. Now, one thing I also want to point out, much like with our linear inequalities, if this were strictly less than, this would have been a dashed parabola. But since it's less than or equal to, it's a solid parabola. When I use this test point, I have is 0 less than or equal to 0 squared plus 2 times 0 plus 4. Is 0 less than or equal to 4? Yes. So we would shade where 0, 0 is. We would shade this test point. We shade underneath the parabola. So as you can see, it's fairly simple. Not too bad at all. Just like when we did linear inequalities. We can also solve quadratic inequalities, both graphically and algebraically. We're going to look at algebraically first because we don't always have access to graph paper. It's always nice to be able to do things just straightforward algebraically. So we're going to solve this just like we've been doing in steps 10 and 12. We can use factoring, the quadratic formula, completing the square root method. We could even use graphing if we wanted, but again, we're trying to do this algebraically, so we're not going to consider that option. Then we're going to plot our solutions on a number line. We're going to test a point from each interval that we've created, and then we're going to write our answer in both set builder notation as well as interval notation. Let's solve this. If I solve the related quadratic equation, that would be x squared plus x equals 2. First thing, I have to get all of my terms on the left. Then I look at this and say, well, can I factor it? Are there two numbers that multiply to -2 and combine to 1? And the answer is yes, 2 and -1. So when I solve each of these by setting each piece equal to 0, I get x equals -2 or x equals 1. So on my number line, grab my number line over here. Here's 0, 1, 2, 3, 4, 5, -1, -2, and so on. I need to put a closed dot at -2 and a closed dot at 1. Again, I'm using a closed dot because this was less than or equal to. Next, I'm going to pick some points on each interval. You can almost imagine that I just took this number line and I broke it into 3 sections. I broke it into this yellow region, then I broke it again and I had this green region, and finally this blue region. So I need to pick a point on each of those 3 regions and decide if it's a piece that I want to keep or to get rid of. So the first point I'm going to pick in the yellow region, how about -4? Let's go back to our original problem here and see if it's true. -4 squared plus -4, is that less than or equal to 2? Well, this would give me 16 minus 4, which is 12, which is not less than or equal to 2. So I do not want to keep this piece. Next, I'm going to pick a point on the green region. I love picking 0. That's always a nice, easy point to plug in and substitute. And when I test that point, going back to my original equation again, 0 plus 0, is that less than or equal to 2? Yes. So we want to keep that part. And next, I'm going to test a point on my third region, my blue segment. How about we try 3? When I put 3 back through my equation, 3 squared plus 3, is that less than or equal to 2? Now that would be 12, which is not less than or equal to 2. So we want to get rid of that piece also. So my answer is right here. X is greater than -2, but less than 1. So using set builder notation, it would look like this. -2, less than or equal to x, less than or equal to 1. Say x, such that. That's what that vertical line means, such that. Now I could also write it with interval notation, which would be -2, comma 1 with hard brackets. Either one of those would be an acceptable answer. All right, let's try the next one. It's already got all the terms on the left, so I'm just thinking, okay, are there 2 numbers that multiply to 30 that would combine to give me 0? Excuse me, combine to give me 11. I should probably not talk and write at the same time. This gets me into trouble. And the answer is yes, 6 and 5. 6 times 5 makes 30. 6 plus 5 gives me 11. When I solve each of these, I get x equals -5 or x equals -6. So we grab our number line and we plot these points. -5 with a closed dot. Now, it's hard to see, but I do have 3 pieces of my number line still. I have the blue piece on the right, I have the green piece in the middle, and I have this yellow piece to the left. I need to pick points on each one of those to see if I should keep that piece of the number line or get rid of it. So choosing a point here on the yellow region, like maybe -7, -7 squared plus 11 times -7 plus 30, is that greater than or equal to 0? Does that give me a positive number basically? 49 minus 77 plus 30, is that greater than or equal to 0? Let's use our calculator. We end up with 2 greater than or equal to 0, so yes, we'll keep that part. We'll keep the yellow piece. Let's check a point in the middle. Now this gets tricky because we have to pick a fraction. But fractions are numbers too, or decimals. So next I'm going to pick the point -5.5. -5.5 squared plus 11 times -5.5 plus 30. Is that greater than or equal to 0? -5.5 squared minus 55 plus 30. I end up with -0.25, which is not greater than or equal to 0. So I'm not going to keep this piece of my number line. Testing my third point. Some point over here, well look, we've got 0, that's a nice easy one to check. 0 plus 0 plus 30, greater than or equal to 0? Yes, so I know I want to keep that piece. How do we write this? Well, the yellow piece would be expressed as x is less than or equal to -6, and the blue piece, let's say, or x is greater than or equal to -5. That's how I could write it in set builder notation, or if I want to use interval notation, I would say -∞ to -6, or -5 to infinity. Now what would this look like graphically? Well, if I graph this quadratic over here, again, I'm going to save some time and utilize the graphing technologies into graphing calculator. Get a nice graph. I'm going to look at my table of values to get some nice numbers that I can plot. I can plot points like -5, 0, -6, 0. We also have the point -4, 2, -3, 6. I can see that my vertex would be somewhere in this region. So I also have these points. So when I graph it, I end up with this. Now, if I were graphing with a Y right here, I would shade below this quadratic. I would shade this whole area down here. If we were doing this like the first problem we did today. But I'm not graphing in 2 variables. I'm trying to graph it in 1 variable. So what I literally want to know is not all of this yellow region. I just want to know where this graph is greater than 0. So y equals 0 is right here. Where is the graph above 0? Well, it's above 0 right here, and it's above 0 right here. but right here it is not above 0. See if I can kind of zoom in a little bit for you. So this piece right here is where it is not above 0. So looking at the x-axis for my solutions, it is above 0 when x is less than 6 or when x is greater than -5. So you can see where that number line comes from. It can come from a 2-axis coordinate plane. All right, how do we finally write an inequality from a graph? Well, one option is to use the method that we used earlier in step 10, which is the matrix method, where you find 3 points, put them through the matrix, and find your answer. If you're comfortable with that method, keep using that method. That was very similar to worksheet step 10C. You can continue doing it that way. However, if we have our vertex form, which we learned also, y equals a times the quantity x minus h, the quantity squared plus k, we can just use the vertex and one other point and solve for a. Let me show you what I mean, like on this example. Our vertex in this example is the point 1, 7. Then I'm going to pick any other point. How about 2, 6? That'll be my second point. So h is 1, k is 7, x is 2, y is 6. And I just plug these 4 numbers into my variables here. Y is 6, a, I don't know what that is, x is 2, h is 1, k is 7. So solving, 2 minus 1 is 1 squared, it's just 1, plus 7, subtracting 7 from both sides, a is -1. So then I go back to my equation, y equals a x minus h. What was h again? 1 plus k, which is 7. And I have to square that. That's my answer. I can easily get that into standard form by multiplying x minus 1 times x minus 1, which gives me x squared minus 2x plus 1, multiplying that by a negative and adding 7, because it's -1 times that binomial plus 7. When I do that, I get -x squared plus 2x minus 1 plus 7 will be plus 6. But that is the equality or the equation. We need the inequality. How would I show shading under the quadratic? Well, let's test it. Let's make it less than or equal to, since it's under the quadratic. And then let's test a point. 0, 0 is a nice easy point to try. Is 0 less than or equal to 0 squared plus 2 times 0, just putting 0, 0 in here. Is 0 less than 6? It is, so I know I've picked the correct symbol. So I would either need to have it in vertex form or in standard form. Both of these would be acceptable ways to write the equation of that inequality.